come back. We are continuing our discussion on introductory calculus, where we are looking at the definite integral. So we have examples on the board where we are told to evaluate the integral of x squared with respect to x, the limits, the lower limit 1, the upper limit 2. So these two are examples of definite integrals. They are definite integrals because the limits are given. The limits that we are talking about are these two figures. We have 1 here and 2 here. So 1 is called the lower limit and 2 is called the upper limit. Similarly here for B, -1 is called the lower limit and +2 is called the upper limit. So when an integral has the limits, it is called a definite integral. When a particular integral has no limits, it is called an indefinite integral. These ones have limits, so we are classifying them under definite integrals. So let's learn how to evaluate them. So we are saying solutions. 1a, we have the integral of x squared, values of x, 1 and 2. So we integrate the function inside the usual way we do it by the rule. So according to the rule, our function x power 2, we integrate it by adding a 1 to the power, then dividing by the new power. So we add a 1 to the power, we divide by the new power. So our current power here is 2. So we add a 1 to the power 2, we divide by the new power. So we have x power 2 plus 1, everything over the new power 2 plus 1. Not forgetting the limits of integration. Okay, so this is the integral of x power 2 with respect to x. So we proceed as follows. X power 3 over 3, the limits 2 and 1. Okay, so this is what we are getting after integrating the function x power 2. We should note that when we are evaluating definite integrals, we do not add the arbitrary constant. So that's why we have not said plus c. C is the arbitrary constant. Now, we do not add it here simply because this one is a definite integral. So when we are here, we are now supposed to substitute in the limits. So we shall say, we substitute the upper limits, we shall say 2 power 3 over 3, whatever we shall get from here, we subtract whatever we shall get after substituting the lower limit. Okay. is how we are proceeding from here. We substitute the upper limit in there, we are getting this, and we also subtract whatever we get, we subtract whatever we are going to get after substituting the lower limit where we have x like that. So we continue 2 to the power 3 will give us 8. So we have 8 over 3 minus 1 to the power 3 is actually 1 over 3. So when we are here, since the denominator is the same, we are just going to evaluate what is numerator. So we shall just say 8 minus 1, and we shall get 7 over 3. We have done this because the denominator is the same. So when the denominator is the same, we just work with the numerator, we just subtract the numerator as we have been given. 8 minus 1 is 7. So 7 over 3 or 2 and 1 over 3 is the value of this integral. Now, watch out for the units. The units, for now, the units are supposed to be square units. Supposed to be square units. The units are supposed to be square units. Because actually, the definite integral is a way of getting the area under a curve. Area under a curve. So it's a way of getting the area on the x or y plane. So area on the x or y plane is found in square units. So basically, this is what we are getting. This is what we are getting as the value of the definite integral under A. Okay, let's look at the other question on B. Okay, so B, we have okay, so this is what we have under B. So again, we are supposed to integrate the function inside, then evaluate it using our limits. We have the lower limit, -1, and the upper limit, +2. So we shall say, as usual, integrating by the rule, we have two terms here. We have 2x and -3. Integrating by the rule, we shall look at the power. So you can see here we have 2x. The way x is as a power 1. So according to integration by the rule, we add the 1 to the power. We divide by the new power. And we have the minus here. Again, we have 3. Now, when we are integrating, we need to show our working, we need to show our calculations. So, a constant, since we are integrating with respect to x, this constant, -3, has the x, only that it is raised to the power 3, power 0, sorry. So, according to the rule of integration, we say we add the 1 to the power, we divide by the new power. Okay, so basically, this is what we are going to have. Okay, so continuing from there, we have 2x power 2 over 2 minus 3x over 1. Okay. Which is giving us, you can see, 2 into 2 is 1, 2 into 2 is 1. So, for this one we have x power 2 minus 3x, limits 2 and negative 1. Okay, so this is what we have after integrating the function inside here. We have x power 2 minus 3x. Now, let us use the limits of integration. So we shall proceed. We say we substitute the upper limit wherever we have x in our integral. So we shall have 2 power 2 minus 3 divided by 2. Okay, so we have substituted in the upper limit, whatever we shall get, and we subtract the, again now we substitute the lower limit here, so that we have minus 1 power 2 minus 3 minus 1. Okay, so that is basically what we have. Okay, so substituting the upper limit, we have this. Substituting the lower limit, we have this. So whatever we shall get after substituting the lower limit, we shall subtract from whatever we shall get after substituting the upper limit. So we proceed as follows. So from here, we have 2 power 2 give us a 4, minus 3 times 2 give us minus 6, minus this minus here, minus 1 to the power 2, minus 1 or to the power 2, we have positive 1, minus 3 multiplied by minus 1, we have plus 3. Okay, this will give us 4 minus 6 will give us minus 2, and then this minus here, 1 plus 3 will give us 4. Okay, so this is now what we have. So from here we have minus 2, from here we have positive 4, and the minus between them. Okay, so this simply means our final value of the integral is minus 2 minus 4, which will give us minus 6. So basically, this is the value of the integral under discussion. So negative 6 is the value of the definite integral under discussion. So basically, this is how we evaluate definite integrals. Thank you very much for your attention.